As we've been working with evaluating limits, we've looked at several algebraic techniques. We've looked at the dividing out technique, where we were able to factor and cancel out a common factor to simplify our fractions. We also looked at using a rationalizing technique. Another example of a way that we can end up using a dividing out technique is when we have these complex fractions. In other words, we have a fraction within a fraction. Now, if I try to evaluate this limit as x approaches -4, up here in the numerator, I'm going to get 1/4 plus 1 over -4, which is going to make my numerator become 0. And then in my denominator, 4 plus -4 would also be 0. So once again, if we try to use direct substitution, we end up with our indeterminate form. And again, anytime we get the indeterminate form, that usually means that there's some type of algebraic simplification that can be done. What we're going to use for our strategy with complex fractions is actually creating the numerator or denominator, wherever your complex fractions are. We're going to actually combine these two together as a single fraction using just our basic properties of fractions here. So in order to add those two fractions in the numerator, I know that they need to have a common denominator. So between 4 and x, our common denominator would be 4x. So in order to make this fraction become 4x, I would need to multiply the numerator and the denominator by x. So this would become x over 4x. And in order to make this have that common denominator of 4x, I would need to multiply the numerator and denominator by 4. So this would become 4 divided by 4x. Once these have a common denominator, then I know I can go ahead and add them together by adding my numerators and keeping my denominators the same. So x plus 4 would become, in my numerator, x plus 4 all over that quantity of 4x. And that big fraction is now going to be dividing by that 4 plus x from the original problem. Now you might say, well, you just made this more complex looking than the original problem. But now by turning this into a single fraction, I can use my property of fractions to simplify. When we have a fraction divided by a quantity, we can multiply by a reciprocal, or as you guys were taught, keep, change, flip. So I'm going to keep my numerator. So I'm going to use that combined fraction of x plus 4 divided by 4x. I'm going to change my fraction bar here to multiplication. And I'm going to flip the 4 plus x over to its reciprocal, which is 1 over 4 plus x. What I have now is an example where, again, I can divide out those common factors. I can take this x plus 4 and divide it out with 4 plus x, because we know addition's commutative. So finally, I'm left with just 1 divided by 4x. So now I can go ahead and evaluate my limit, replacing this x with -4, and I'm going to end up with 1 over -16, or better known as -1/16. So anytime you encounter a limit with a complex fraction, you're going to find your common denominator, add those fractions or subtract depending on what the problem asks you to do, merge them into a single fraction, and then just rewrite it using your definition for division with fractions. Do your keep, change, flip, keep your numerator, change your division bar to multiplication, and then flip over your denominator, and then you should be able to simplify and get an answer from there. If you have any questions, let me know.